They chose the Gulf of Mexico, a vast, deep expanse. But what if that specific coordinates weren't for safety, but for access? A monumental key turning in an oceanic lock, unleashing something long dormant. For millennia, humanity has gazed at the stars, always been an irresistible frontier. The 20th century transformed this curiosity into capability, ushering in the space age. The startling beep of Sputnik 1, the awe-inspiring sight of Yuri Gagarin circling Earth, and the indelible footprint of Neil Armstrong on the lunar surface. These moments didn't just break new ground, they redefined what we believed was possible. For decades, space exploration was predominantly a government endeavor, a colossal undertaking driven by Cold War rivalries and scientific curiosity. Agencies like NASA, Roscosmos, and ESA pushed the boundaries, building the International Space Station, a beacon of global collaboration orbiting our planet. But as the 21st century dawned, a new force emerged: private enterprise. Visionaries, fueled by audacious dreams and entrepreneurial spirit, began to challenge the traditional paradigm. They saw not just a frontier for exploration, but a canvas for innovation, aiming to make space travel more accessible, more frequent, and ultimately sustainable. This shift has ignited a new race, not for flags on the moon, but for the very future of humanity, a future where we are not just Earthbound, but a multi-planetary species. This ambition, grand and almost unfathomable, is embodied in one particular starship, a vessel poised to redefine our cosmic destiny.
At the forefront of this new era stands SpaceX, founded by Elon Musk with the explicit mission to make life multi-planetary. Their journey began with the Falcon 9 rocket, a marvel of engineering that proved rocketry didn't have to be disposable. Its ability to land vertically and be reused revolutionized the economics of space access, dramatically lowering costs and increasing flight frequency. But Falcon 9, impressive as it is, was merely a stepping stone, a proof of concept for something far grander: Starship. This colossal vehicle, designed to be fully reusable from nose to tail, is not just a rocket. It's envisioned as humanity's primary transport system to Mars, a lunar lander, and even a high-speed point-to-point Earth transport. Standing nearly 400 feet tall when stacked with its super-heavy booster, Starship is the most powerful rocket ever conceived, dwarfing even the Saturn V that took Apollo to the moon. Its stainless steel skin gleams under the Texas sun, a testament to its radical design and manufacturing approach. The vision is simple yet profound: build a fleet of these ships, refuel them in orbit, and send hundreds of people and vast amounts of cargo across the solar system. It's a vision that demands unprecedented engineering solutions, constant innovation, and a willingness to learn from every setback. The development of Starship has been a spectacle unlike any other in aerospace history. At Starbase, SpaceX's sprawling facility in Boca Chica, Texas, prototypes are built, tested, and often explode in spectacular fashion. This iterative, rapid-fire development process, dubbed Rapid Unscheduled Disassembly, is central to SpaceX's philosophy: fail fast, learn faster. Each explosive test, each belly flop maneuver gone wrong, provided invaluable data, pushing the design closer to perfection. The sheer complexity of Starship is staggering. It's not just about raw power, it's about precision. The most critical and visually arresting part of Starship's atmospheric re-entry and landing sequence is the belly flop maneuver. The immense vessel pitches horizontally, using its body and fins as a giant air brake to decelerate from orbital velocities. Then, just moments before touchdown, it performs a daring flip, igniting its Raptor engines to transition to a vertical landing. This dance with gravity demands incredible control and flawless execution. For the initial orbital flight tests, a full return to launch site landing is deemed too risky. Instead, the focus has shifted to a controlled splashdown in the Gulf of Mexico. This strategic decision allows SpaceX to collect critical re-entry and atmospheric flight data without the added complexity of a precision landing back on land. It's a pragmatic step, a calculated risk, moving us closer to the ultimate goal.
The Starship test flight culminating in a Gulf of Mexico landing is more than just a splashdown, it's a pivotal moment in human history. The sequence begins with Starship's ascent into orbit, then a controlled re-entry over the Gulf. As it plunges back through Earth's atmosphere, the extreme heat and aerodynamic forces will put its revolutionary design and materials to the ultimate test. The belly flop maneuver, refined through countless simulations and test flights, will manage its descent, slowing it down from hypersonic speeds. Finally, with a plume of steam and a tremendous roar, it will execute its flip and propulsive landing, aiming for a precise, controlled splashdown in the designated clearout zone. This isn't about recovery of the vehicle itself for this initial test, it's about meticulous data collection. Sensors on board will transmit vital information about thermal protection, structural integrity, and flight dynamics, providing engineers with unprecedented insights into Starship's performance. Extensive environmental impact assessments have been conducted, and mitigation strategies are in place to ensure the safety of marine life and the ecosystem. A successful Gulf landing will validate key re-entry technologies and flight profiles, marking a monumental step toward routine reusability. It means we are one step closer to establishing a permanent human presence on the Moon, building sustainable cities on Mars, and fundamentally altering our relationship with the cosmos. The echoes of that splashdown will resonate far beyond the waters of the Gulf, heralding a future where space is no longer a distant dream, but our next home. Subscribe to the channel and hit the bell icon for more amazing videos.